Hi, welcome back to the next chapter of the series for the niniBUS. Today is going to be a fun chapter, right? Till now, we have discussed a lot of things. I have so I have shown a small part of the code and try to create a mental model um, to explain my design or my thinking process. Mhm. Uh, to give you more perspective, this project is not to create another message queue kind of thing and claim it to be unique in some way or other, right? So this is mostly a engineering journey, and we should do like uh, how do we start, like how my design is evolving, how my thinking process is evolving, how the architecture is going to evolve, and at the end we will try to provide a uh, polished output. That's why the universe exists, right? So we have gone through the mental model. I will be going through all those things to reiterate in this video, and then I will be going through the code, right? So before going to the code, reiterating the things which we have discussed will be a good refresher, and it will create much more interest in looking into the code, right? Looking into the code is a boring part. I always understood. Someone written a code, you want to just go through it. It doesn't seems interesting. So that's why I just want to reiterate about the mental model once more. That will help us to debug few, help us to go through the code. Okay, so I always have a idea that there are two things. One is your concept, your mental model, your architecture. Second part is your code, your implementation, right? Always you try to align your architecture to your implementation, right? But at the end, your implementation is something which is going to run, right? So the implementation or the code is the source of truth. Architecture for me is a source of inspiration. Okay, that's how it should look. Even though I tell that this is how architecture I'm designing, my code may be a little bit deroot from here and there, and that's okay, right? That's how the code design, because whatever the architecture is, it will it's little bit loosely kind of things, right? It doesn't always tell the exact concrete things, and the code is little bit more concrete because that's how you design, right? That's how do you write. When you write, you think to optimize every line of code. You think to write a better code, right? That's how the code always a little bit deroot from your design, right? And that's I think it's fine. But the code is a source of truth. That's the source of, because that is something which will be in your machine or in your device which is going to run. Okay. Enough of the story. Let's come back to the mental model. That's what we thought of discussing today, right? Okay. That's what we are discussing today. So the mental model, what we learned till now is that uh, just a moment, let me get the window. Okay. So the mental model is something we need to understand a little bit more, so that will be going to be much more helpful, right? I hope mm, it's looks okay now, right? Yeah, let me put it myself and leave it down. Let's make it a little bigger. I'm not good at all those technology though. That's fine. I don't need to be right. And that's okay. No need to do much things here. I'll just put it myself at a corner. Okay, so let's go into the mental model. Okay, so always try to get the mental model first. Like how do I follow, right? If I have to any day, if I have to, or it may work when I have to read a code base. My always the idea is create a mental model, go to the include files, then go to the source code like .c, .cpp or anything. Yeah, the reason being, the mental model will give you the idea about your data structures, how things stored. The include file will tell the implementation details of those data structure, right? It will tell, okay, data are stored in this fashion and we have few APIs or contracts that is implemented in the code, but these are the contracts, right? That's how things design. Okay, so let's go through this first. Okay, what we learned till today is that our idea is simple. We are not going to implement multi-producer, multi-consumer system till now, which eventually we will do towards the, how this thing's going to evolve. And today, at this moment, my data structure or this project is still a single threaded, right? There is no multi-threaded. In a single thread, you have a publisher, you have a consumer, or you can have multiple publisher, multiple consumer. That's also a different thing. We're not yet reached to there also. Okay, so the only idea is we are able to publish, we are to receive by the consumer. That's how we are designing, right? So the first design philosophy, what we did, we have, okay, we have created a map. All right, we have created a map, and we created two APIs which are user facing. So okay, one is the first one which we created, publish, and the second one we created, receive. This is this two API or contract we are giving to the user, okay, or the application. So publish means we are taking one data and putting into a lane, right? So we know, right, that we are a lane. So in a lane, we will be the publisher put the data on the lane, and the receiver will read the data from this lane. That's how it is designed, right? Simple as it is. Okay. So now the idea is publisher is publishing to a lane, and we have defined there is something called lane ID. We have something we have defined. There is something called lane ID, and we have a create one object called lane, right? A class we have created called lane. Okay. So every lane ID, every time a publisher publish, we going to ask a publisher the API contract what you are providing. You have to send. You have to tell me what is your lane ID and what is your message, right? And what I will return you back, I will return you back the result, publish result, right? And for the receiver, what I am telling, you send me your lane ID and pass me a string variable. I will take as a reference, and I will put whatever the data was there for this lane ID, I will put it into your message, right? I will give you back. So I'm expecting the receiver should send me a buffer, Okay, string. Okay, and I will return you some result which I will call receive status. Okay, so these are two contracts I have created. Okay, so now I have created a map. The idea of the map is every time I get a lane ID, I will create an object. I will create an object and store this one in the map. Okay. So first time the publish something. If the lane ID does not exist in my map, what I will do, I will create that lane and map that one, right, with the lane ID. Okay. Let me remove this one. Okay. So the idea here is I have an unordered map. Okay. In which I will have a lane ID one key and value is the object what I create for that one, right? So this will be a lane. So at the time the publisher publish something 100, the publisher publish 100 and some message like hello. Okay, my first job is I will try to figure it out is this 100 ID is available in the map. If it is yes, then I will get the object and I will do something, right? I will put the new message there. If it's not, it's a new. I will put an entry here 100 and I will create an object. Okay, one lane object. That's what I'm doing. So if I try to create a class around it, right? Let's create a class. So in this class, I will have these two APIs, which is the public APIs, right? A contract. And I will have a private variable, which going to hold the map, because the map is something outside people cannot see. I am managing, my boss is managing. So I will have a unordered map of a lane ID and lane, right? Lane class. We'll go to the lane class and I will have something. This map name is something called lane map. Okay. This part is my first class. Okay. And this is called niniBUS.h. Let's go and see into the code. Okay. So if you can think here, you can see here, I have a nini, sorry, that's not this one, that's not the correct one. Let's go to the niniBUS.h. As we told, right, I have a lane ID and a lane and a map, right, and two contract publish and receive and a create lane which I created because sometime I want to create a lane telling that my lane have 100 capacity. I will be discussing this part. Okay, we're also going to discuss, but let me go through these two first and we'll go to why create lane exists and why it's required. Okay, now so if you see, I have an unordered map called lane map and it have a class lane t. Now go to the lane t class and see what it's actually having. Nice. So the point here of the lane t is, so the lane t here is, I have a class called lane t. Okay. I don't want the public contract what we have to carry the queue, okay, because I will have multiple lanes and I don't want to have a class which carry the queue. Okay, so the lane t class, I'm trying to have a class, I'm trying to have a data structure for the queue. Okay. So the idea is I have to have the queue here, right? Now what? Now what? Okay. The queue is a bounded one, right? It's a bounded one. So I need someone to tell me the capacity of the queue, right? Okay, nice, nice. I have two variables now, one queue, one capacity. I don't think the capacity is the part of the queue. How when I'm trying to create the queue, I have to pass the capacity, right? Okay, that means somehow I have to pass the capacity to the queue. So what I did, I created a queue class and given the name of this class is nini FIFO. Okay, nini FIFO is a class which is creating the queue for me, right? Okay, so I have a new class called nini FIFO. Okay, this is a new class I'm creating because I can use directly a queue, but I want to have more control on my queue. Instead of directly going to use an STL, I'm trying to have more control. Because at the end, this is something going to evolve slowly when we have a multiple producer, multiple consumer, when we will have a producer, multiple consumer, the queue data structure, what is part of the STL may not meet my requirement, and I understood this queue data structure I need to have my own so that I can design it, right? That's why I've created a nini FIFO queue, and the name of this one I've given a content. Okay, the variable is content. Okay, that's fine. Now okay, what else this class require? Okay, as we discussed, right, we are going to return publish result, right? When I call the publish, I am returning publish result. That's what I'm returning, right? And I'm calling publish. When I'm calling publish, I am sending lane ID and message actually I'm trying to push into this object. Alright, when I'm trying to hello, what I'm trying to do here is I'm trying to find this 100 object is there. If it is there, it's okay, we'll go forward. If it is not there, I'll create an object. Okay, so if you know, there is something called try emplace. Okay, what this try emplace do? It's okay. What it do? It loosely. It's not loosely. What it do is it try to it return two things. Try emplace on a map. So this is my map, right? Lane map. Let me make it a little bit clear. So what it will do, I will put like lane map dot try emplace, and I will try emplace this lane ID 100. Right, it will return two things. It will return iterator and a inserted. Okay, iterator me okay, what it will do, if it is there in the queue, the iterator will give me the iterator of that 100, right? If it is not there, if the 100 is not there, the try emplace will create that object, put into this map, and it will give me back the iterator. Okay, so now if I get the iterator, I can reach to this person. So I have this person. Now what I'll do, I have to put that message in the queue. So what I'll do it dot second. Okay, I think it's a pointer. It dot second dot push and the message. Okay, so the push is part of the lane object. That means I need to implement this part, right, in the lane class. So I have to have this push function. Okay, I have to have this push function and some message string. All right, this is my public contract. I'm giving it to you. This is my public contract. Okay. Then when I'm popping, I'm receiving, I will have a pop operation is required. And in that I need a string message, right? I have written you back these two things I return. Okay. I have two things now, push and pop. But actually, do you think this push and pop are the part of the queue? Are the part of the queue, not here. Not here. It's part of the queue. So from the push and pop, what I'm actually going to do is I will try to implement the push. Okay. And I will push into the queue this content. So what you will do, I will do content dot push back this message. And whatever the queue is returning, that is something is queue should return what? Success or failure. So if it is success, alright. Then what I have to return? What I have to return from the push function? I cannot return because at the end I have to return publish result, and you know, right? We have a backpressure thing. That I have to tell that how many slots are available in the queue at this moment. For how many slots are available for this lane? That means I need to have something get credit function, right? Get credit. Right? I have to have something called get credit. What is get credit? I want to know that, hey buddy, hey Q, you to tell me how much Q is free or how much Q slots are filled. Okay, got it. So I need to something called get credit. So again, this get credit, what it will be happen? This get credit function is here. Now I have to implement this get credit. I have to implement the get credit. And how are you going to ask? You are going to ask the queue. You are going to ask the queue, hey, return me the size of yours. That is my, if I have the capacity value, which I have, and if I return, if you queue your content, return your content dot size, whatever this value is, that is my credit. That is my credit. That much space is available. So at this moment, I will return here. I will return get credit and success. Right, that I am going to show you how this looks. Okay, I'm just trying to create the data structure around it first. Understood. So we have a get credit, we have a push, we have a pause. Okay, now tell me, do I need this get credit to be public or private? It's a private thing. I don't have a contract. I don't want anybody to read it. Okay, only the contract is push and pop for you. You push it, pop it. I will give you the result you back. I don't, you as a bus on the top, you don't have to read me, my credit. I will provide you the result, but you don't have to read me. Right? You have only contract for push and pop. I will give you result there only. That means this need to be private part. Q. Q. Q is another data structure. I am taking the data structure. Do you want? No, you don't have to look into it. You have a bus, niniBUS. You don't have to look in how I am managing the queue. What is my abstraction? I don't want to tell you. You put push, you get a pop. That's all for you. So all those things are going to be private part. And these two are going to be public because these are the contracts. Right? Okay. So this tell me my new class which is called Lane T. Okay, this is my new class Lane T, and here is the implementation. Okay, I'm not going to throw each and each line of the code right now. I'm just trying to create a mental model so that you can go through the code and identify. Okay, so I've given enough reason, right? Why I'm creating I've given enough reason why I'm creating the niniFIFO queue, right? because at the end this is something which is going to evolve, right, slowly and slowly. That's the idea of an this project, right? We are going to try. At the beginning we started with skew, then we thought, okay, we can have a vector, and slowly I evolved that I need this FIFO so that it can handle what I want. A single queue have a producer, have a consumer, that's fine. But when you have multiple consumer, you have to have some additional things in your data structure which can help you, right? So the STL queue also fine. You can use it and you can create something around it. But if I have my own queue, I have more like what do you call privileged. Okay, I can make it evolve slowly. Right? That's why I created. Now think of how the Nini FIFO is going to looks like, right? So the Nini FIFO is nothing but a data structure, right? I'm trying to make it as a trying to follow the STL conversation, right? STL type, right? Like, okay. So we know it should behave like a queue. That means I have a queue. In queue, I have few things, right? I know in a queue, data comes first, leaves first, right? That means whenever you're trying to push the data, you are putting into the tail, right? You are putting into the tail. And when you're trying to pop the data, you are taking it from the head, right? Okay. 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 You read the data from you put the data in the tail and you read the data from the head, right? And I told you something. It's a bounded. Bounded means I have a variable called capacity. I have a variable called capacity. That is something actually telling me what is my capacity, right? I should not go beyond that capacity, right? That means the capacity is the number of slots. Let I have 4 slots. That's how it will be created. I will create. So that's what the create lane do actually. The create lane we saw at niniBUS dot, right? Create lane actually pass the capacity for a lane, right? And it actually jumps from niniBUS to the lane, from the lane to the skew data structure. Tell, hey, user told you to take this capacity. If not, if user didn't provide, the lane dot h actually provide. Okay, how did let's talk this one? The capacity transfer from the user, right? So the create lane. So it will come to niniBUS.h. Okay, it's come to here. Now this go to lane.h because this is how that transfer is flowing, right? Now this is transmitting to Nini FIFO. This is how this variable is flowing. Okay. So this is with this create lane API. Okay. But you can think of I have something called lazy lane concept, right? Here you don't have to create the lane, you can directly publish because helps you to not to create unnecessary code, right? You don't need this one. Okay, but in this case, how this capacity will be derived? So in that case, what my idea is this lane.h will create the lane object for 100. It will send you a default capacity, right? And this will be reached to here as a capacity, right? You got the contract, right? That's how it's going to work. Okay, let's jump. Let's jump. We have took little detour, and that is required. Okay, so what you understood that we have a queue of some capacity, and let for this moment I'm making it 4 for making the code understandable, right? So what we learn, this Q is a FIFO, fast in, fast out, and have a capacity. So at starting, the head and tail both are at 0. Okay, I am putting you this way. Uh, People used to count from 0, 1, 2, 3. I am putting because it's a, I'm just trying to make it a Q, right? So this is the Q door. Alright, it's a Q door. Okay, so every time you put, people come from back and come here, right? This will be flowing, data will flow like this, right? This is just trying to create an imagination, visual representation. Okay, so that's why I'm putting 0, 1, 2, 3 this way. Okay, the indexes of the array. Okay, it's a storage, right? We just storage. So I'm creating an array. Okay, I can have a vector. I'm creating, making it a vector. The reason being for the array, the problem is it need a compile time, variable size, right? And with this create lane, we cannot have that mm, privilege, right? That's why I'm using vector. Again, your question is if your question is come, a vector is again STL. You are using the STL. Yes, at this moment I'm using it, and because I'm using it, I know it's a continuous data will come, a continuous memory will come, and I can have indexes to play with this indexes, right? But pointing to that, this vector data structure are going to change. Okay, we are not going to stay with the vector for a long time. Okay, because the vector, when you create a vector, it allocates a memory from heap, right? And it have its own metadata. And my idea at this moment, what I'm thinking, I don't want anything from the heap. I know I don't want. I will make some data structure as per the vector, and I'll create some allocator kind of thing, and which will help me. I'm not going to heap actually. Okay, I don't want to go there. I want to make it isolate. Hey, I am this much. You give me this much of memory, I will create, and I will create from my memory. I am not going to interact with the heap and everything. I am not going to do it. Okay, I will have my own memory pool or memory box. You tell me this lane is 10 slots, I will take that 10 slot from my memory box. I will be bounded. Okay, not the queue. I want this total universe to be bounded. I can claim it, then only I can claim it. Okay, I am using nothing except this memory what you have provided me. You have provided me 1 MB. I am going to use those 1 MB only. I am not going to use other things. Okay, I did it. Let's come back. Let's come back. Okay, so your head is here, your tail is here, right? The fast data came, fast data came. Okay, this is your buffer. What you do? You do buffer, so you put that on the tail. You don't put that on the tail. Okay, put tail your data. Okay, data is like some xxx data. Now what will do? Your tail should increase. You should increase your tail plus plus. Okay, because I'm using a vector and I have an idea that later I'm going to change this size or change this vector also, right? So what I'm with this I'm doing, I'm using some size variable to increase. This is the size of, right? This is the size of current to the size of this queue or this buffer 2, right? After this putting that is 1. That's what I require to get calculate the credit, right? The credit will be now what will be 4 minus 1, which is 3. That's what I need it, right? That I have to return. The size I have to return to the person who is calling me. Okay, because they want to calculate the credit. Okay. Okay, now I put a tail. Now again one more data came. You put it again into tail. Okay, the tail is here, your head is here. Now it came to your tail. Now here. Now what happened? Bounded. Now a new tail came. Okay, and the new tail came. Okay, I already have a check and balance in the niniBUS publish also, right? Hmm? That if my lane is already full, if the lane is already full, if queue is already full, the lane itself will return lane full, right? And credit 0. fine. But still I'm going to implement this part because once the head is, someone take the data from the head, right? Take the data from head. Now this buffer is free. So my tail need to come to here, right? That's why it's simple thing, right? You do tail percent equals to tail by capacity, right? This modulo. Similarly for the head also you are going to do the same thing. So this is a push operation, right? This is a push back, because every day I'm putting the back. Okay, this is a push back operation. And similarly you have to write a pop from the front. Pop from the front. So what it will do? It will read this, just the head will be plus plus, and again the side will be now minus minus, because I consumed it, I pop it, right? And my head will be like head by capacity, right? And because I'm trying to make it like a STL, in STL if you know, right, this Q doesn't return anything in pop front, right? It return, if you read front, it will tell you exactly what is data in the front, right? That's what I'm also implementing. So this will return the simple return buffer head, right? Okay, that's how it's going to implement. Okay, so now what I need, so these are two contracts, these are three contracts, right? Pushback, pop front, and front. These are the three things my layer going to read the data and give it to the return back to the user, right? So these are the three things, right? So my FIFO, my niniFIFO is having now three things, right? niniFIFO. What you understood now? In this class, I will have a vector. Oops. T is a template I'm using, right? A buffer. Then I have some variable called head. Some head, some tail, something called capacity, something called size. Right? Do you think these are need to be public? No, doesn't need to be public. For the public, what I have contracts? I have a push front is my contract. Pop back is my contract. Sorry, we are doing something wrong here. The contract is push at the back. Q is always back, not front. Push back is my contract. Pop front is my contract. Front is my contract, and what else? I need to tell my size also, right? So size is my contract. So these need to be public, and all other things can be private. Simple. Now we completed, right? We started from niniBUS, we reached to the LAN. From LAN we created another data structure called niniFIFO, and which is going to a core business, which is going to be evolved, right? That's why I've created, instead of using Q directly from the C++, we've created it so that those functions, right, those functions can stay alive until, and we will modify this one, right? Slowly. So this is the last class what we have created it till now, right? That's all. Let's go through the code. I told you whatever I'm telling, this architecture and all those things, that's okay, but code is the source of truth. Okay, now let's follow. Okay, so simple. I have a string. We already gone through niniBUS.h. Let's just for the sake of it, let's do this part, publish. What I discussed, that auto it iterator try and place len id. Yeah, great. If the map it doesn't have this key, it will clear the key and give back to the iterator. If it is already that id is there, it will already give the iterator. If I get the iterator, I'll just push second push. So the second push is actually going to the len.h. So len.h have two things: push pop. That is your contract, right? That's the contract you got. That from the niniBUS will have only push and pop, nothing else. And I have a queue here, nini FIFO, that's what we discussed. Then I have a credit. Nothing. The credit telling, hey, tell me your capacity. Hey, string, tell me capacity. And what is the current size? That's all. That's the credit left. Get pending message. And how many messages are still pending in your queue? Tell me. That is my size. Alright. Because I need to return you back. Got to publish result because that's what I have to return. Right. So return I have to return with the credit and the status. Status is simply telling, okay, I am able to put the data already, and if I not, my line is full. If it is okay, I will return you okay plus plus what, how many slots are available, what is your credit, you have the LAN, have how much credit is left in the LAN. Okay, I will send you okay and okay credit. If the LAN is full, like I don't, you have the LAN is full, then I will tell you the credit is 0 and status is LAN full. Right. Same for received result. Tell me number of pending message I have and I am able to read it or not. That's okay. LAN create. Okay, that's receive status. Okay. Lazy LAN is empty and lazy LAN is created. Lazy LAN is something we have discussed, right? That if you directly trying to subscribe or receive the status, right? It can happen, right? In an embedded world, when we have multiple threads, just a forward thinking because you're not implementing thread part. Just a forward thinking. It's possible, right, that you have a thread consumer which can come first. Okay. So at that time, instead of directly telling the LAN there is no LAN, I know if the consumer is asking for this thread for this ID, that means I sooner or later there will be a publisher for it. So instead of telling, hey, nothing is for you, I will create a LAN for you at least. Okay, so that next time publisher come, you directly put the data. That's what the lazy LAN created, right? Nice, that's fine. Now go to the LAN.h. Okay, now we have a nini FIFO. Okay. So if you have, yeah, one more thing. If you see the LAN T, if you see when I'm creating the LAN object, I'm passing this default LAN capacity, which is 10. That is the queue capacity actually, right? If you see this when I'm creating a LAN object, it automatically going to create this one also, right? Because it have object. So I'm passing the content and capacity, right? So the constructor of this content will be called with this capacity, and the capacity can be, if you are not passed anything, the default LAN capacity will be go, right? That's how we designed it. Okay, let's come to niniBUS niniFIFO.h. Simple, right? FIFO status successful empty, right? That queue is full, empty, or you are getting a reading able to read the data, right? Success. Capacity, that's what we discussed. We have a vector, buffer, head, tail, and size. Okay, if we get the capacity, okay, capacity we get when this object is getting created, and when this object will get created, this object will get created whenever they will publish, or whenever there is a create LAN. Okay, that time only this try in place will create a LAN ID with capacity. If it is creating a LAN, because you want your LAN to have you define your size, so you pass that LAN ID and your capacity. If you pass capacity 0, hey, it's not possible, right? I will just tell you invalid capacity. I will return you invalid capacity. Hey, this is not the way you should work. And 0 means what? You don't want to LAN, you're just mocking me. That's not the business I'm doing. I'm doing some serious business here. So I'll tell you if your capacity is 0, I'll set an invalid capacity. Bro, buddy. And I cannot go forward. I'm not going to create anything for you. But if you really want some capacity for your LAN ID, I will create for you, buddy. I will create for you. I'll pass LAN ID and capacity, and this is here. We're going to create the object LAN.h, and which will going to call this constructor. When we call this constructor, we will call this content constructor, and the content constructor will go to here. Alright, that's where everything is defined. That's how the nini FIFO is defined. Okay. Yeah, you got it. Buffer capacity, buffer capacity is because this is a vector. This is an initializer list. Okay, this will be initialized with this much of size. Right. Then head is tail 0, tail is 0. We discussed. Head is 0, tail is 0. I'm not able to show it. Okay. Yeah, size is 0. Nothing is there. First time, right? Now post back if queue is full, body return FIFO status is full. Okay, how I'm calculating full? So the full, I have a contract here. Full is size equal to capacity. Right? Every time I put a data, my size will increase. I read a data, I pop a data, my size will decrease. Right? Don't think that if you reach the last index, you are always full. No, you're not full. You are not reading the index to identify this. It's a full or empty. You are checking size. Size is telling exactly if someone taken the data. That means you have a slot free, right? That's why it's full. How? So the full and empty is there. Empty will tell you what is the size. If size is 0, that means empty, right? If the size is equal to the capacity and no one have read it, that means I am full. So I have success. Okay. I will saw empty. I will return a full. I will return empty. Okay. The pop front message buffer tell increment the tail and modulo the capacity. That's what we did. Increment the size if it is pushing back. If you are reading from the front, you are popping from the front. Return back size it. Decrease side head also going to go once forward. Okay, the front is returning the buffer head, right? That's what the contract, right? Right? So now if I go to niniBUS CPP, if you can understand total flow, publish, hey, try in place, okay, then post it and return. And what the post is doing? The post is doing nothing. This post is doing a postback message. FIFO status is success. That means I am able to put the data. Okay. Then that means okay. I will return back okay. The credit. If there is no success, that means land is full at this moment, nothing else is implemented yet. So success, empty, full. Alright. For the push, it should be full, right? So if you're not able to success, I will tell the land is full and return 0. But no credit. Don't have a credit. I'm trying to pop it out. Right? Pop if content is empty. Okay, it's not empty. If not empty, read the content. Return back the message, right? Message is content front. Once you read this content, you pop it, because right, that's how we implement it. Because this niniBUS is following a little bit of nini FIFO, following a little bit of STL side, right? Pop front doesn't, or the front doesn't pop it out. We have a pop front and a front. Front is to read the data, right? So we read the data, now pop it and return back. What I'm going to return you? How many messages are pending for you? Right, that's what I'm going to return. And if the queue is empty, land is empty, you have received, you don't have anything to receive. It's 0. Alright. That's how the code looks like. Okay. This is a big, this is a little bit, what I call, little bit lengthy video, but interesting one, right? Because we've gone through the code. And one thing I want to show you, that's what is required. If this tells us our first table release. We have a release now. First table release of niniBUS bounded per Lane FIFO that we discussed. Custom circular FIFO implemented. So we did up to some extent. Sorry. Runtime Lane capacity. Yeah, we did it. We calculated the capacity during runtime, right? We said create Lane is runtime, right? It's not a compile time. Create Lane. Lane credit and nib approach inspired from TCP flow control. Same as pending, right? explicit land creation. That's, I think both are same thing, right? And we have a FIFO comprehensive till now, and some integration which can also have created, some design document have updated. Now, this release establishes a single threaded competing consumer baseline. Okay, what do you mean by computing consumer? I just want to give you a hint what the next milestone for us or I am going to design. So think of at this moment what we are doing. We are trying to put the data into the LAN and some consumer will read the data. Once the data is read, that is gone from the queue. Done. If there is a second consumer for the same LAN, he will not get the data. So what is happening if I have three data 1, 2, 3 data are put into the queue by the publisher, the first consumer will read the 1, second consumer will not able to read the 1 because it's popped, but second consumer is going to read the 2. So that means the consumer have to compete who wants to come first. Okay, that's what that's what the competing consumer, right? Yeah. Now, but for the next release, the B2, the one more engineering challenge we're going to fix or design with architect, discuss broadcast delivery, right? It's not competing consumer. If a data is put into the queue 1, 2, 3, if I have three consumer who want to that data, they should read both, everyone should read 1, 2 and 3. It's not, they don't have to compete with each other. That's what the B2 is going to do. Okay. So every release we will have some engineering problem to be solved. Okay. This is not an project for any particular what is it called, message queue, any particular message queue, right? Or I am not going to claim it, right? Anything, but this the engineering journey which I am experiencing, and I am recording it, logging it, journaling it uh, for everyone, right? Okay, and for my benefit also. Okay, hope we'll be start the B2 milestone, and before I start the B2 milestone, writing the code, execute, I will going through a lot of document research and all those things to I'm going to do all those things. The reason being, now the actually the engineering chaos came into picture, right? Till this time, what we did is we create something boring and concrete, make it work. Okay. Now the next part is things going to chaos. So for that, I'm trying to read few papers, trying to go through various articles to identify which is what type of designs are available, and I can going to choose one or not choose anything, or I may find something interesting, some inspiration, and create something else. Not sure at this moment, honestly. But yeah, I'll create multiple way of architecture. I'll figure it out, and I'll have a video. I'm going to have a video about the multiple architecture, and I will tell why I am not choosing this one, why I am not choosing that one, not choosing one, not choosing two, not choosing three, and why I choose four, or why I am not able to choose anything yet. We will be discussing slowly. Okay. Till that time, I hope you have enjoyed this series, and please go and look into the code. Also, that's the beautiful thing, right? That's the source of truth. Make it boring and make it concrete. That's the philosophy. Okay. Hopefully, we will see in the next lecture. Take care. Bye.